Welcome to the discussion of question numbers 11 to 20 of SLMC number 13. So let's dive straight into the problems, and there are some fun questions here. So first one, again, I'm not highlighting the methods. I would just show you how I would do the problems again, thinking very efficiently in the process. Okay, but there might be certain theories that you can use, so I can also highlight that. But again, this is all about thinking efficiently, fast, and then correctly. Okay, so this one right here. Sarat, Abdul, Meena, Kamala, and Susan have different numbers of marbles totaling 125 marbles. So all of them has to have at least one marble. What is the greatest number of marbles can person with the greatest number of marbles have? So initially when I saw that question, so let me just, what I wanted to do is just try a number. For example, 122 or 121 and 1111. Well, this doesn't satisfy my condition, right? Because it's still 125, but it is not different number of marbles. Okay, so I just want to maximize this guy. Okay, but then I have to have different numbers. So the smallest number I can have is 1, and then I must have 2, and then the next possible choice is 3, and the next possible choice is 4, and then whatever remaining would be 115 because that's 10. So the largest number you can have is 115. Okay, let's move on to the next one. A three-digit number is balanced if the middle digit is the arithmetic mean of the other two digits. So you have a number A, B, C. B must be equal to A plus C over 2. Okay. So what are the choices that have? Well, of course, this should be an integer. So let's say I have choices uh, 1. So A must be at least 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then what are the choices for C? Well, if this is 1, then I can't have an even number for C. So it should be either 1, 3, 5, 7, 9. Okay. And then, of course, you get the other number. And here, for when A equals 2, you cannot have an odd number. So you can have 0, 2, 4, 8. Yeah, that's all. Okay, and then again, I'm not considering the place where n is 0. Okay, so there are 4 choices here. There are 5 choices here. And then if it's 3, then you can have 1, 3, 5, 7, 9. So it just gets um, alternating. Okay, so you have total 9, and there are 5 such pairs. So it's 9 times 5, 45. There might be different ways of solving this problem. For example, thinking of what A and B. So for example, you have A, B, C, then this is a balanced number, then C, B, A is also a balanced number. And by recognizing patterns, you should also be able to do this problem. This one had me stumped for a moment. The following two intersecting rectangles divide the space inside the rectangle into 3 regions. Now, what is the largest number of regions inside one or both rectangles one can create using 2 intersecting rectangles? So immediately, let's just do a hand computation. So if you have something like this, you can have 1, 2, 3, 4, 5 regions. And then I was trying to think of, okay, what else you can do? Well, nothing much, except you can think diagonally. Okay, so I was thinking that, well, keep moving just keep them vertical and horizontal. That's the best you can do. However, if you think diagonally, and take two rectangles, now you can see that the areas, the regions can be maximized. So you have 1 2 3 4 1 2 3 4 5 6 7 8 and 9 regions. Okay, again my editing was a little bad here. Okay, but anyway, this is probably like what made me go wrong is because I was thinking the horizontal vertical part. But when I see the diagonal, when you intersect it diagonally, you can have these smaller regions, and then that would maximize the number of regions. And I don't think, I mean, another thing that uh, you can use is that these questions are well formed. Okay, well formed means there can be only one answer, or sometimes you can have two answers, but that's all. Okay, the answer is there, which means you can use that in SLMC, which is a luxury that you don't have in SLMCC, right? Tic-Tac-Toe, okay, favorite games. One player use crosses and the other one use knots. Um, and of course, you know the basic rules of Tic-Tac-Toe. And the reason why you are in SLMC is you love these type of games. Uh, if the game ends in a draw, what is the total number of moves? Of course, the moves has to be exhausted. So you'll have to have exhaust all moves. So that means you have 9 moves. I mean, it can be many different moves here. So for example, um, okay, and then this is not a draw. Okay. Um, so in this case, you can't have two. So this, okay. And then, yeah, that's a draw. Okay, so when you draw, you have to exhaust all the moves. Next one. Let me just draw this grid in a visible color here. So you are doing tic-tac-toe, and here you have XXOO. So Meena can win in the next move by placing X in the top row middle square. Of course she can, because she can now because the idea of tic-tac-toe is you make the move undefendable, because you can defend only once. So if this happens, if the person if Abdul put 0 here, Meena can put the cross here. So there are two places to protect that cannot be done. So this is the correct one. So you can just select it. But then again, Meena can also win. Meena can also win if she places the cross here, because again, it is undefendable. You can, after the next move, you can either put the cross here or here. So both of these choices are correct. Now, this is a rare instance where you find two answers in correct in SLMC, but whatever these answers would be correct. 22. Another thing is the nice idea is that whenever you have a SLMC in a particular year, that the number of year comes in many different questions. So it's a good idea to know the factors of 2025 and how this number 2025. It's I believe, because it's a square number and it has some other fantastic properties. I believe 2025 will feature heavily in SLMC 2025. Okay, just something that I always notice. Uh, so this 2023 caps are divided among n students. So it's an arithmetic sequence. Now I'm not gonna use a lot of mathematics that you learn in the class. So I'll try my best to not use any formulas here. So let's say what you have here is A, and then A times some K, and then a times sum 2k, a plus, and then a plus sum 3k, and you have n terms, because there are n students. So you have a plus n minus 1k. If it is a plus nk, you will have n plus 1 terms. Right. So what is the sum? Well, again, I'm not using the formula. I try to avoid formulas as much as possible for SLMC. Okay, so here I have NAs, and then k times 1 plus 2 plus up to n minus 1, and that is my 2023. Okay, I'll have to use a formula now. Now this sum is n times n minus 1 over 2. Okay, so I have NA plus k over 2 n times n minus 1. I didn't say I would avoid algebra. I was trying to avoid formulas, but I can see that this is the easiest way to go. So I have n a plus k over 2 n minus 1. Now, this is not a fraction. K over 2 n times n minus 1 is not a fraction because this is a product of two consecutive numbers. And also, from here, because this is an integer, this must be an integer as well. And also, by looking at this is n is a factor, and then this is also a factor. Okay, but this doesn't matter to me. This is the only thing that matters to me. It is a factor. So whatever the number is, it must be a factor of 2023. So n is a factor of 2023. So the factors of 2023 are 7 and 17. So it must be 7. This is one of those questions where you think of a theory, it might take you a long term, but again, this is not about applying theories. This is about solving the problems the easiest way you can. So integers a, b, c, and d satisfies the equality. So I'm guessing this is a multiplication. 20 times ab equals 23 times cd. So if this is and it doesn't say that A, B, C are distinct. So one of the pairs that satisfies would be A equals 23 and AB equals 23 and CD equals 20. And then which of the following can be the ABCD product? Of course, you can see that 460 is an ABCD product. So I would say that's the answer. Okay. 4 integer numbers have sum S and product 16. Now, again, SLMC is multiple choice questions. So if this was a free response question, I will mostly think of positive numbers because my brain would register as integer numbers as positive number. Don't fall into that trap. You can have negative numbers. So now you can see the negative numbers are there and the sum is S and the product is 16. So you want to maximize um, minimize that number. So how about negative 16 and then negative 1, negative 1, negative 1. And if you want to make this smaller, you can see that you can't go really below negative 19. So the sum would be negative 19. That would be the smallest sum. Okay. How many solutions does the equation x minus 1 absolute value minus 1 absolute value equals 1 have? So you can actually solve this as absolute value x minus 1 minus 1 equals 1, or absolute value negative of absolute value x minus 1 minus 1 equals 1. And then you can again, absolute x minus 1 equals 2. So x minus 1 equals 2, or x minus 1 equals -2. So here x minus 1 absolute minus yeah plus 1 equals 1. So you get x minus 1 equals 0. So you get the three answers. X equals 1, x equals 2, sorry, x equals 3, or x equals -1. So you get three answers. Now, if you're an A-level student who know a little bit about absolute value graphs, you can still solve this graphically, which was my go-to method when I was solving this. So x minus 1 would be this, and then you bring it down 1 unit when you do x minus 1 absolute -1. So you will have something like this. And when you take the absolute value, instead of going down, you will go up. And then you will shift the whole graph, because this is also thinking about, just like thinking about this -1. And this -1 will push this graph 1 unit below. So you will have something like this. And you can see there are 3 points that intersect. So the answer is 3. And finally, how many distinct factors that does 2023 squared have? So it is, at this point, it is like you have to remember the factors of this particular year. So that is 2023. And you have, it's 7 times 17 squared, which means 2023 squared would be 7 squared times 17 to the power 4. So let's break it down. So you have 7 0, 7 1, and 7 2. And on this side, you have 17 0, 17 1, 17 2, 17 3, and 17 4. So each of these pairs will give you a distinct factor. Okay. And you have 3 choices here, and you have 4 choices here. So altogether, you have 12 choices. Okay. Right. Hold on. Sorry, my bad. 5 choices here. So it would be altogether 15 choices. Okay. So I hope you enjoyed that part, and I hope you understand the approach or the philosophy behind SLMC. This is, again, remember, this is not for A-level students. This is not for O-level students. This is for students who love math, which means it doesn't have to be any theory or anything that you know. Most of the time, you should be able to do it just with the mathematics sense rather than mathematics theory. Okay, so that's my whole point. There might be different ways to solve this problem. So I hope you enjoyed this video, and I hope you also adopt these approaches when you do SLMC. Thank you so much. I will get back to you from 21 to 30. Thank you.